Hey guys. So today we're going to continue, well actually we're going to start our new section 312, how can I rewrite it, where we're rewriting expressions and determining if they're equivalent or not. So a little bit of a continuation of what we did in the previous section, but just kind of diving in a little bit more, getting a little bit more in depth. So problem 14. 314, they want you to think of the area model and rewrite it using multiplication. So for A, they wanted us to use the area model to relate the expression 2x minus 3 times 3x plus 1 and this 6x squared minus 7x minus 3, kind of looking at the equivalence of them. So they actually started the problem with for you, and they actually determined, they used the area model. So the area model, sometimes we refer to it as the box method. I like the area model a little bit better because it actually does show you the area of that box that we are figuring out. So I do like using area model as opposed to box, right? When it comes to the area model, this is a binomial and another binomial, so it's a 2 by 2, and they're just putting those binomials on the outside, right? Because that's what we're going to multiply through by. It doesn't matter where you put your binomial. I think a lot of times we like to put it on the left and on the top, which is perfectly fine. Here they just put it on the left and on the bottom. And through this section they kind of move around where they have that, just so that way you guys get used to it doesn't necessarily have to be on the left and the top. It can be kind of placed anywhere because you're just using that multiplication to figure those out. And then if we sit there after they figured out the terms that were in the inside of the area, then they combined like terms, and then they ended up with 6x squared. They combined the x's to get negative 7x, and then you still have that negative 3 and that negative 3, right? So we've been kind of working with those. We've worked with them in the past, and then we're working with them again now. So B wants us to sit there and actually figure out the area model. Use the area model to find the expression equivalent to 5x minus 3 and 2 times 2x minus 1. So area model, we need to make that area or that model. So when we look at this, I know that this here is a binomial. Bi means two terms. So that 5k is one term, negative 3 is the second term. Again, we get another binomial, and it doesn't have to be, it could be any polynomial, but this is a binomial as well. Two terms, 2k, and then negative 1. So when it comes to making my model, I know that my model has to be a 2 by 2. So let's start off with, what are we on, B, right? So we're going to make our box, or our model, and we know that it had to be a 2 by 2. And then we can put our terms wherever we would like. So I'm going to put them just on top, what we're used to, 5k minus 3 and 2k minus 1. And then we're going to go through and multiply these. Okay? We've been doing these. 5k times 2k is going to give me 10k squared. 2k times negative 3 is going to give me negative 6k. 5k times negative 1 is negative 5k. And negative 3 times negative 1 is going to give me a positive 3. So most of the time our like terms are on diagonals, so we can simplify this, and we have what? 10k squared minus 11k's plus 3. So this is equivalent, whoops, sorry, my bad, wrong one. This one is equivalent to this one, right? So for C, oops, they want us to actually come up with that model. They're giving us this trinomial, and they want us to take that trinomial, put it into the area model, and then come up with what our factors are. So we're really doing just the opposite of what we did for B. So I'm going to make my, my model. I'm going to go by a 2 by 2 model. I'm going to have my x squared in my first box, and I'm going to have my -4 in that bottom box. Because if we go back here, remember that middle term, those k's were what was going on that diagonal. So the same thing's going to happen here on this diagonal. Is going to be, we have some x's that we got to figure out. So we just got to figure out what's going with our x's. So we know that we are multiplying. Actually, let's go back a second. We can fill in some of our outsides. So to get x squared, we need to figure out what is it that we can multiply in order to get x squared. Well, we can multiply x times x to get x squared, right? And you can do these in any order. You don't have to jump around. So we know that we have to multiply this factor by this factor in order to get -4. So we need to figure out the different ways of getting -4. So one thing is to get a negative number, the only way you can multiply two numbers to get a negative is one has to be positive and the other one has to be negative, right? They have to be opposite signs to be a negative. So to get to -4, I can either do 1 times 4 or I can do 2 times 2, right? And when I combine this diagonal, it has to combine to be -3. So I have to figure out what combination of these factors is going to get me to a -3. Well, we can cross off the 2 by 2 automatically. There's no way 2 plus 2, 2 minus 2, nothing's going to get us to -3. So it's got to be the 1 and the 4. And in order for it to be a -3, it's got to be a -4 plus a 1x, right? So you can fill this all out first and then pull out those like factors to figure out how to get there. So like I said just a little bit ago, to get x squared, we knew that that was x times x, right? So to figure out this guy, right, we can do x times what is going to get me to a -4x. Well, that's going to be a -4, right? And then you can check it. X times -4 gives me -4x, right? Up here, you can go, so we have x times what is going to get me to 1x. Well, just a 1, right? A positive 1. And then now you can actually go through and check this to make sure. X times x is x squared. X times 1 is 1x. X times -4 is -4x. 1 times -4 is -4. So now I can write my factors. So from the top, I ended up getting an x plus 1 factor, and from the left, I have an x minus 4 factor. So this guy and this guy are equivalent. They're just written in a different form. We're used to taking this, and by all means, you can do, remember how we did the x, a times c, and a b? You can do that as well to figure out the factors if you don't want to do the area model. All right. So today's problems are just really a whole lot of, so today is just a whole lot of problems, a whole lot of examples of doing these types of problems. So for 15, it says to rewrite each of the following products as a sum and each sum as a product. Draw an area model where appropriate, right? So we're just finding some equivalent forms on these. So if we start off with A, and A, I'm just going to rewrite it, 2x squared plus 5x plus 2. So on this one, we want to write it as an area model, right? I have 3 terms, so I know that my area is going to be a 2 by 2 to give me 4 terms. My first term is going to be 2x squared. My last term is going to be a 2. So now I need to figure out what to put in my diagonal. Right? So a times c is 4. So I got to multiply to get to 4. and then when I add them together, I got to get 5. So again, how can I get 4? I can either do 1 times 4, or I can do 2 times 2. And I have to get to a positive, so they either both have to be positive or they both have to be negative. This guy's telling me they both got to be positive, so I know I got a positive and a positive. To get 5, the only way this is going to get me to 4, this will get me to 5, right? So I'd have 1x and 4x's. So now, what do I have to multiply in order to get 2x squared? Well, I'm going to have a 2x and an x. It's the only way I can get to 2x squared. So then we can go down, right? So I got to get 4x squared. So 2x times what is going to get me to 4x? So I need that to be a 2. Back to my highlighter. X times what is going to get me to 1x? Well, that one's just going to be another plus 1. And then I can just double check to make sure that I'm getting 2 down here. 2 times 1 gives me my 2. So then now I can find my factors. So on top I have 2x plus 1, and on the left I have x plus 2. Right? For B, we don't have to do all of these problems. We'll kind of jump around a little bit. For B, I want to draw that area model, but on my B I have a binomial, which means I have 2 terms, and this one is a trinomial, which means I have 3 terms. So if I have a 2 by 3, or if I have 2 terms and 3 terms, then to find out my area, I need to make a little bit bigger box. I have 2 terms and I have 3 terms. So I have to make it a 2 by 3. And then I'm going to put my 3x minus 1 on the left, and then x plus 2y minus 4 on the top. So then I'm just using multiplication, right? X times 3x is 3x squared. 2 times 3 is 6, and then x times y. Negative 12x, negative x, negative 2y, and positive 4. And then I'm going to look to see if I can combine my like terms. So on this one, they're not quite on the diagonal, so we got to kind of hunt around a little bit for these. So I have 3x squared, and then I'm going to go with x's, just right. So I have negative 13x's. Then I'm going to throw in the xy's plus 6xy, and then I only have the negative 2y, and then the plus 4. Okay. I threw some, oops. Let me go back to that for a second, let you catch up on your writing. Alright. And then I just copied the problem again, just because I knew I wouldn't have room to keep going with A, B, C, D, E, and F, right? But if we look at C, we've been working on these ones. This one's going to give you, when it comes to your area model, you're just going to have a 2 by 2, and you can multiply that one out. On E is a lot like the B that we just did, right, where you have a 2 by 3. D, so we got to work on D. D is a little bit different, right? And F is a little bit different. So let's look at D real quick. So D, we have 4x squared minus 49, right? So on this one, because I have this little square, I know I could, if it helps, because you don't have your x term on here, if it helps, you could actually rewrite this. This is the same thing as 4x squared plus, we don't have any x's, so that would be 0x minus 49, right? So now when I go to draw my area box, I know I have 4x squared and I have negative 49. So now I need to figure out what's going on my diagonal, right? So somehow I got to get to 0x. So that kind of gives us a clue that one of these has got to be positive and one of them's got to be negative. Granted, when we multiply, we're getting a negative, so we know it's negative 49, so one has to be positive, one has to be negative. The other clue is in order to get that 0, one has to be positive and one has to be negative. And we have our x's in here, so I'll throw the x's. A great clue of having that 0 in there means that these are perfect squares, so whatever is positive is going to be negative, so for poops and giggles. If this was a positive 5, we knew this has to be a negative 5 for those to cancel out. So we know that it's a perfect square. So to figure out what the perfect square is, though, we had to do 4 times 9, or sorry, 4 times 49. 4 times 49 is, we're almost to 50, or 200 minus 4, 196, right? And then because I know it's a perfect square, then I can just take that square root of 196 and I'm going to get 14. So I know it's a positive 14 and a negative 14. Right? So then when it comes to figuring out my terms, to get 4x, I can either go 2x and 2x, right? Or I could go 4x and x. So this is where we just got to think ahead a little bit. If I did 4x and x, when I multiply here, I have to get negative 14. So that would be 4 times what is negative 14. It's not going to work, right? So we know we can't have a 4x up there. So we're going to go with a 2x and a 2x. Right? And then 2x times what's going to give me a negative 14x, negative 7. Right? 2x times what is going to get me to a positive 14. That's going to be a positive 7. Right? And then just to double check, 7 times negative 7 is going to give me a negative 49. So I can write this as 2x plus 7, 2x minus 7. Nice. All right. Let's talk about f real quick. So on f has kind of a 2 parts to it. So they start off with this 4 minus x times x squared plus 1. And then they want you to add on this 3x minus 5, right? So they're getting all wild and crazy on us. So by orders of operation, we have to multiply before we can add, right? So this binomial is being multiplied by that binomial. There's technically a multiplication right there. And then they're adding on this binomial. So the first thing we have to do is, I can never brackets, right? We have to multiply these two together. So we're going to use that area model to multiply these two together to simplify it, and then we're going to add these two on there, right? So we're just gonna, I'm not gonna do the whole problem for you guys, so you guys got some practice on these. So this is 4 minus x, and this is x squared plus 1. You're gonna fill out all of that. You're going to simplify it down into a new little, ooh, look at that. You're gonna simplify it down, right? And then you're going to add that 3x minus 5. Combine like terms, and then you're gonna get your, now I can do an oval. Now you're gonna get that new answer. Alright. Alright. Beautiful. On 317, they have us going in just the opposite order is what we kind of have been working on. So on this one, they gave us that area model, and then out of that area model, they want us to be able to fill in all of the little pieces, right? So if we look at A, and like on this one, like I said, remember how they're going to start scrambling up where they put all of the factors on the outside, or all of the terms on the outside? So they did this on us. So I'm going to start off by just looking at this first box, right? Excuse me. So on this first box, they get x times y. So I know that I have to multiply an x and a y together, and they gave me the x down here for this box, so I got to figure out this side of the box. And what's that side of the box going to be? You named it. That's going to be y, right? And then now I can kind of move forward. What about this box? So figure out the area of a box. It's like that length times width, right? So it would be this times this. So we know this one is 3 and this is y. So that's going to give us 3y. And then now, this last box, length times width, they gave me the y, so I still need to multiply by y. So you can either throw it on the top or on the bottom. It doesn't matter. So now when I go to figure out how I'm multiplying this, so for the whole entire thing, it'd be this times this. So I'd have y times, and then you got to kind of piece it together because they got the x down here, the 3 up here, and we put the y up here. So that would give me x plus 3 plus y. All right. Let's jump over here to b. Okay. So on b, again, they gave us some parts to it, and we just need to fill in all of the rest and figure out what's going on. So I'm going to start up here in the top left with my x squared. So I know length times width. How am I going to get x squared? X times x. Right? To get to the bottom, I have 8x. So I know I have x times something is going to give me 8x. So I know that's got to be an 8. And if you want to, throw a positive in front of it if it helps you when it comes to figuring out the overall factors. Right? They gave us a 3 for this length, right? So these lengths right here are all 3. So to figure out this box, it's going to be this times this. So it's going to be x times 3, which is going to give us 3x. Right? And then our bottom is going to be length times width. So 8 times 3. 8 times 3 is 24. Right? So if we combine it, so our factors are going to be, oh, whoops, I forgot. Whoop, whoop, whoop. One more. Forgot my top. Oh, no, I didn't get the 3 on the bottom. I apologize. Yep. So if I look at how far is this across, well, this was x, and this was plus 3, so that's plus 3. So that's going to give me x plus 3. And then on my side, I'm going to have x plus 8. Right. And then if we wanted to, whoops, I forgot. We can combine all of the stuff in the inside, and we can actually come up with another way of writing this, right? So this would be the same thing as x squared. I would have 11 x's plus 24. Same thing on a, right? I can go through and I can combine. I'm just going to write it as y squared plus 3y plus xy, right? All right. Let's work on C. I think D and B are pretty close to each other, so I'm going to let you guys do D, and I'm going to try and do C, right? We're going to do C. So with C, they gave us some stuff here in the inside, they gave us some stuff on the outside, so we need to figure out all of the rest. So a lot of times this is a personal preference on where you want to start, and sometimes if you're stuck on one of the boxes, move on to another box and see if you can figure out what that box is going to be. Okay? So let's say we wanted to figure out this, oops, I always lose my highlighter. Let's say we wanted to figure out this box. So this box would be like our length times our width. So on C, oops, so they gave us some stuff on the inside. They gave us some stuff on the outside. And we just need to be able to figure out all of the other little pieces. So sometimes this is a little confusing, like where do I start? You can almost kind of start anywhere in some regards. If you're trying to figure out one of the boxes and you can't figure out that box, then move on to another box. Like if I wanted to figure out what this box is, well, I know it's going to be a length times a width. Well, guess what? I don't know any of my lengths. Like I don't know this one, I don't know this one, I don't know this one, and I don't know this one. And when it comes to, like, I don't know this, I don't know this, and I don't know this. So you know what? Maybe that's not where I want to start. Maybe I want to try someplace else. So maybe I want to try this box, right? So in order to figure out this box, it's got to be my length. And do I know my length? Oh yeah, it's right there. And I need to know a height. Do I know the height? Oh yeah, it's right there. So I know I can fill in that box because I'm just going to multiply those two together and I'm going to get 14y. Right? So then now I'm just going to sit there and go, well, I'm going to move up and I'm going to look at this negative 20xy. Because in order to get negative 20xy, I have to do this side times this side. And do I know one of my sides? Yeah, I know that it's negative 4y. So I have to multiply by negative 4y in order to get negative 20xy. So to get a negative, one's got to be positive, one's got to be negative. My bottom's already negative, so I know that the left is going to be a positive. Then I'm going to go number by number and variable by variable. Right? So 4 times what is going to get me to 20? 5. So I'm going to throw my 5 there. I have, my variable is y, but I need to get xy, so I still need to multiply by a x. And then I'm going to double check it. 5x times negative 4y is going to give me negative xy. So I'm like, hey, I'm starting to get someplace, right? So let's see if we can figure out anything with this box or with this piece, right? So to get negative 15, I get my length times my width, right? Oh, I know that my length, I know that this piece is negative 3, so negative 3 times what is going to get me to negative 15? Oh, 5, right? And if anything, throw a positive 5 on there, right? Just to help out. Let's try this box, right? To figure out this box, I need to know this side times this side. Do I know this side? Yeah, that side's 5x. Do I know the base? Yep, the base is now 5. So I can multiply these two together and I get 25x. Right? So now let's go back to our first box. So to figure out our first box, what's this times this? Well, I know this side is 5x, right? But this length, oh wait, I don't know that length yet. But I wonder if this guy could help me out. So to get negative 6x, right, this times this, it would be negative 3 times 2x. Good job. You guys got it, right? So a positive 2x. So now, can I figure out my top box? My length times my width? Yeah. This is 5x. This is 2x. So I'm going to get 10x squared. So I can write it with my factors. So looking on the outsides, right? So I would have 5x minus 3 times 2x minus 4y plus 5, right? That's equivalent. And then the other idea, I could look inside my box, right? And I could combine like terms and see what I come up with. So I have, what, 10x squared X's. Let's see how many X's. I got negative 6x and 25x. That's going to give me what? A positive 19x. And then I got xy's. I don't have any other xy's, so I have minus 20xy. Y's, I got any other y's? Nope, just the one y, or well, 14 of them, right? So plus 14y's. And then whole numbers, we got that whole number, so negative 15. So there's two representations of those equivalent expressions, right? So I'm going to let you guys go ahead and do D on your own. 19, let's just talk about 19. I think I'm running a little long on time. 19, they kind of go through an example and kind of give it to you. And this has to do with perfect squares. We kind of did an example of perfect squares up here with on problem 15D. Those are perfect squares. So they kind of give you a little definition about what perfect squares are. So we're just going to talk about the example. So 16x squared minus y squared. So when it comes to figuring out what these factors are, we can look and see that they are perfect squares. So 16 is a perfect square. That perfect square would be 4 times 4. Right? X squared, perfect square, x times x. In order to get a negative, one has to be positive and one has to be negative. Right? 9 is a perfect square, 3 and 3. Y squared is a perfect square, y and y. So you don't even have to go through and do that whole modeling of that area model in order to figure these guys out. So like if we just skipped and looked at A real quick, so we want to sit there and be able to write this as some perfect squares. So is A squared a perfect square? Yep, A and A. Right? To get a negative, one's got to be positive, one's got to be negative. Is 4 a perfect square? Yep, 2 and 2. Is B squared a perfect square? Absolutely, B and B. And now you have it in factored form. All right. I'm going to let you guys do some practice. I'm here for you all hour, the rest of the hour, if you have any questions.